Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 12 Physics, Current Electricity, Chapter 3, ncert Solution, Part 1. Our mission is to provide free classes on YouTube for all the students of Class 6 to Class 12, special classes for all the students who are preparing for IIT, JEE, NEET, NDA, and other competitive examinations. Before we move to the chapter, we request you to subscribe, like, and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. So the first question of the exercise is 3.1. The storage battery of a car has an EMF of 12 volt. If the external resistance of the battery is 0.4 ohm, what is the maximum current that can be drawn from the battery? So the solution is EMF of the battery E is equal to 12 volt. Internal resistance of the battery R is equal to small r is equal to 0.4 ohm. Maximum resistance of the drawn from the battery, maximum current drawn from the battery is I. According to Ohm's law, E is equal to IN. Therefore, I is equal to E by R, I by R, IR. Therefore, I is equal to E by R. Therefore, E is equal to I by E is equal to IR. Therefore, I is equal to E by R. And putting the value of E and internal resistance R as 12 and 0.4 respectively, we get and our on calculation or after calculation we get 30 ampere. The maximum current drawn from the given battery is 30 ampere. Now let us see the second problem, 3.2. A battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? What is the terminal voltage of the battery when circuit is closed? Let us see the solution of 3.2. So EMF of the battery E is equal to 10 volt, which is given. Internal resistance of the battery R is equal to 3 ohm. Current in the circuit I is equal to 0.5 ampere. Resistance of the circuit resistor, resistance of the resistor is equal to capital R. The relation for the current using Ohm's law is I is equal to E upon R plus R. Therefore, R plus R is equal to E upon I. Putting the value of E and I, we get by 10 and zero point 0.5 respectively, we get, and on calculation, we get R plus R is equal to 20 ohm. Now, terminal voltage, so therefore, on solving the value of R is equal to 20 ohm, R is equal to 20 minus 3, that is 17 ohm. Terminal voltage of the resistor is V. According to Ohm's law, V is equal to IR. Put the value of I and R, 0.5 and 17. We get 8.5 volt. Therefore, the resistance of the resistor is 17 ohm and the terminal voltage is 8.5 volt. So let us move to question number 3.3a. Three resistors A 1 ohm, 2 ohm and 3 ohm are combined in series. What is the total resistance of the combination? So solution of 3.3a is 3 resistor 1 ohm, 2 ohm and 3 ohm are combined in a series. Total resistance of the combination is given by the algebraic sum of the individual resistance. That is, total resistance is equal to 1 plus 2 plus 3 is equal to 6 ohm. Now let us see the B, 3.3b. If the combination of the connected if the combination is connected to a battery of EMF 12 volt and negligible internal resistance, obtain the potential drop across each resistor. So let us see the solution for 3.3b. Current flowing through the circuit is equal to I. EMF of the battery E is equal to 12 volt. Total resistance of the circuit R is equal to 6 ohm. The relation for the current using Ohm's law is I is equal to E by R, that is 16 by R, 12 by 6, which is equal to 2 ampere. Potential drop across 1 ohm resistor is equal to V. From Ohm's law, the value of V1 can be obtained as V1 is equal to 2 into 1 is equal to 2 volt. Equation number 1. Potential drop across 2 ohm resistor is V2. Again, from Ohm's law, the value of V2 can be obtained as V2 is equal to 2 into 2, that is 4 volt. Potential drop across 3 ohm resistor is equal to V3. Again, from Ohm's law, the value of V3 can be obtained as V3 is equal to 2 into 6. So again, the Ohm's law, the value of V2 is again obtained. V2 is equal to 2 into 2, that is 4 volt. Potential drop across 3 ohm resistor V3 is equal to V3, that is again from Ohm's law, the value of V3 can be obtained. V3 is equal to 2 into 3, that is 6 volt. Therefore, the potential drop across 1, 2 and 3 ohm resistor are 2V, 4V and 6V respectively. Now, let us see question number 3.4a. 3 resistor 2 ohm, 4 ohm and 5 ohm are combined in parallel. What is the total resistance of the combination? Solution to 3.4a is there are 3 resistors of resistance R1 is equal to 2 ohm, R2 is equal to 4 ohm, R3 is equal to 5 ohm. They are connected in parallel, hence total resistance R of the combination is given by 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Putting the value of R1, R2 and R3, we get 1 by 2 plus 1 by 4 plus 1 by 5. the LCM is 20, and the after solving we get 19 upon 20. Therefore, value of R is equal to 20 upon 19. Therefore, the total resistance of the combination is 20 upon 19 ohm. Now let us see the question number 3.4 part B. If the combination is connected to a battery of EMF 20 volt and negligible internal resistance, determine the current through each resistor and total current drawn from the battery. The solution of part B is EMF of the battery V is equal to 20 volt. Current I1 flowing through resistor R1 is given by I1 is equal to V by R1, that is 20 upon 2, that is 10 ampere. Current I2 flowing through resistor R2 is given by I2 is equal to V upon R2, that is 20 upon 4, that is 5 ampere. Now current I3 flowing through the resistor R3 is given by I3 is equal to V upon R3, that is 20 upon 5, that is 4 ampere. The total current I is equal to I1 plus I2 plus I3, which putting the value of I1, I2 and I3 as 10, 5 and 4, we get 19 ampere. Therefore, the current through each resistor is 10 ampere, 5 ampere and 4 ampere respectively, and the total current is 19 ampere. Now let us see question number 3.5. At room temperature 27 degrees centigrade, the resistance of a heat element is 100 ohm. What is the temperature of the current if the resistance is found to be 117 ohm? Given that the temperature coefficient of the material of the resistor is 1.7 into 10 to the minus 4 degree centigrade minus 1. Now let us see the solution for 3.5. Room temperature T is equal to 27 degrees centigrade. Resistance of the heating element at T R is equal to 100 ohm. Let T1, so resistance of the heating element is T1. R is equal to 100 ohm. Let T1 is the increased temperature of the uh, filament. The resistance of the heating element at T1 is equal to R1 is equal to 100 and 17 ohm. Temperature of the coefficient of the material of the filament alpha is equal to 1.7 into 10 to the power minus 4 degree per centigrade. Alpha is given by the relation alpha is equal to R1 minus R upon R T1 minus T. This is the formula you should remember. So T1 minus T is equal to R1 minus R upon R alpha. T1 minus 27 is equal to 117 minus 100 upon 100, 1.5, 1.7 into 10 to the minus 4. T1 minus 27 is equal to 1000. T1 is equal to 1027 degrees centigrade. Therefore, at 1027 degrees centigrade, the resistance of the element is and the resistance of the element is 117 ohm. Now let us move to the sum number 3.6. A negligible small current is passed through a wire of length 15 meter and uniform cross section 6 into 10 to the minus 7 meter square, and its resistance is measured to be 5 ohm. What is the resistivity of the material and the temperature at the temperature of the experiment? So the solution of the problem 3.6 is length of the wire is equal to L is equal to 15 meter. Area of cross section of the wire A is equal to 6 into 10 to the power minus 7 meter square. Resistance of the material of the wire is resistivity. It should be the resistivity. So resistivity of the material of the wire is rho. Resistance is related with resistivity as R is equal to rho L by A. Therefore, rho is equal to R multiplied by A upon L, where A is the cross-sectional area, L is the length. Now, putting the value of R, A, and L, we get 5 into 6 into 10 to the minus 7 upon 15. Upon solving, we get 2 into 10 to the minus 7 ohm meter. Therefore, the resistivity of the material is 2 into 10 to the power minus 7 ohm meter. Now let us solve problem number 3.7. A silver wire has a resistance of 2.1 ohm at 27.5 degrees centigrade and a resistance of 2.7 ohm at 100 degrees centigrade. Determine the temperature coefficient of resistivity of silver. So temperature T1 is equal to 27.7 degrees centigrade. Resistance of silver wire at T1 is equal R1 is equal to 2.1 ohm. Temperature T2 is equal to 100 degrees centigrade. Resistance of silver wire at T2 R2 is equal to 2.7 ohm. Temperature coefficient of silver is alpha. It is related to the temperature and resistance as alpha is equal to R2 minus R1 upon R1 bracket T2 minus T1. Now putting the value of R2, R1, T2, T1, we get 27 2.7 minus 2.1 2.1 bracket 100 minus 27.5. Upon solving, we get 0.0039 degree centigrade inverse. Therefore, the temperature coefficient of silver is 0.0039 degree centigrade inverse. Let us do the sum number 3.8. A heating element using nichrome connected to a 230-volt supply draws an in initial current of 3.2 ampere which settles after a few seconds. A steady value of 2.8 ampere. What is the steady temperature of the heating element if the room temperature is 27 degrees centigrade? Temperature coefficient of resistance of nichrome averaged over the temperature range involved is 1.7 into 10 to the minus 4 degree per centigrade. Let us see the solution of 3.8. Supply voltage V is equal to 230 volt. Initial current drawn I1 is equal to 3.2 ampere. Initial resistance is equal to R1, which is given by the relation R1 is equal to V upon I is equal to 230 upon 3.2. After putting the value of V and I, upon solving we get 71.87 ohm. Steady state value of the current I2 is equal to 2.8 A. Resistance of resistance at the steady state R2, which is given as R2 is equal to 230 upon 2.8, that is 82.14 ohm. So temperature coefficient of nichrome, that is alpha is equal to 1.7 into 10 to the minus 4 degree per centigrade. Initial temperature of nichrome T2 is equal to T2. T2 can be obtained by rel relation for alpha, by the relation for alpha. Alpha is equal to R2 minus R1 upon R1 bracket T2 minus T1. So T2 minus 27 degree centigrade is equal to 82.14 minus 71.87 upon 71.87 into 1.7 into 10 to the power minus 4. Upon solving, we get 840.5. Then final value of T2 is equal to degree centigrade. So final value of T2 is equal to 840.5 plus 27, that is 867.5 degrees centigrade. And this is the end of today's class. Let us Before binding up, let us again request you for subscribe, like and share our YouTube channel among your relatives and friends. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you for watching Experience Tutor YouTube channel and supporting us. Thank you very much.